Hello and welcome to this video where we're going to be looking at tensile strength and how to check it. So before we start, we want to see who this video is really for. Now, if you are designing a component from steel, it is imperative that you understand the yield strength and the ultimate tensile strength to ensure your final product meets all of the design criteria, ensuring product safety. So let's have a look at tensile testing. So why is tensile strength so important? Knowing the tensile strength of a steel ensures the manufactured product is safe for use throughout its life expectancy. The result of selecting a steel with a lower tensile strength than the product that is expected to experience can have disastrous consequences and potential fatalities. So how to check the tensile strength of steel? So what is tensile testing? Tensile testing of metals is a destructive test process that provides information about the tensile strength, yield strength and ductility of the material. ASTM A370 is a testing standard that covers the mechanical testing definitions and procedures of steel products. How to check the tensile strength of steel? Well, to start with, we need a sample piece of the metal being tested, which should be produced into the shape shown in the image to the right. Now, this does follow the ASTM A370 guidelines. So the next stage is to load the specimen into the tensile grips on the machine. Attach the extensometer to the sample. Then begin the test by separating the tensile grips at a constant rate of speed. Speed determines the specimen shape and can range from 0.05 to 20 inches per minute. The target time from start of test to break should be from 30 seconds to 5 minutes, depending on the material you're testing, obviously. Now, the end of the test is when the sample breaks or ruptures. Now, the test machine will then be able to produce a full report showing the technical data. Let's have a look at the machine in the next slide to see how we're loading and see what happens with the material. So you can see in this image a tensile test machine with a sample loaded in it. Let's have a closer look at some of these sections. So here you can see the extensometer, which is fitted to the sample piece. You will also see two marks on the sample. Now, these can be used to measure the difference between the start and the finish of the test, as we'll see in the next few slides. This second close-up shows the machine which is pulling the sample piece apart. You can see the sample piece start to reduce in width. This is known as necking. This third close-up actually shows where the sample is broken. This is the end of the test. On this last close-up, you can measure the marks on the sample to see the difference or the dimensional difference from start to finish. This is just a guide. However, remember, the machine will actually generate a full detailed report for you. Let's have a look at some of the results from the machine itself. Obviously, we're going to get the tensile strength. And remember, this is the resistance of a material to breaking under tension. You'll also get the elongation at yield, and this is the amount of extension of an object under stress at the yield point, and you can see that on this graph here. Elongation at break, and this is the amount of extension of an object under stress at fracture, and you can see the fracture point on this graph here as F, and again on this graph here with the cross marked on it. You'll also be able to obtain the nominal strain at break. This is the grip separation. This is the applied load divided by the actual cross-sectional area, or the changing area with respect to time. And you'll be able to obtain the modulus of elasticity, also known as Young's modulus. This is where the elastic deformation is reversible. In other words, the material returns to its original shape after the load is removed. Now, this is shown in this area on the graph. A simple way to calculate the tensile strength is in this formula here, which is TS equals UF divided by A, where TS is the tensile strength, UF is the ultimate force, and A is the cross-sectional area of the force it is acting upon. Now this table here shows a number of different properties of steel. Now here we're obviously looking at tensile strength, which you can see in these values here. If you are developing products for production in Asia, please contact us. Thanks for listening. My name is Paul Adams from Sofeast, and I shall see you in the next video.